We're at the Centre for Fine Print Research in University of West of England. The robot is an RV7, which is a Mitsubishi 6-axis robot. The UWE have connected that to a print generation system.
My primary interest is in robotics, and what I'm interested in is how robots can interact with the world, perceive the world and make their own intelligent decisions. And I think art in particular is interesting because it contains a lot of nuances. The majority of 3D printers work by depositing layers, and they accumulate these layers one after the other to sort of build up an object. But what we're interested in is actually looking at an object and depositing material so that it's sympathetic to the form of the object. Having a robot arm is key because it gives us that freedom and that dexterity to sort of manipulate and get around objects. So these are a variety of objects that we've 3D printed. And I'll actually start with this one. It's actually printed conventionally, and you get quite clear layers on the object. And the overall aesthetic of it is quite consistent. It's a model which demonstrates perhaps mechanical properties or scale. So then relative to that one, these objects are quite different. If we start with this one, you can see this material is quite flexible, it's quite fabric-like, but actually it's the same plastic as this duck. So what we've done here is quite finely controlled the way the machine would deposit the plastic, how it extrudes the plastic and how it manipulates the plastic. And we're able to get this sort of very fine mesh-like or gauze-like material. As the machine is moving, we're speeding up and slowing down both the movement and the extrusion. And so we get these thick deposits and thin deposits. There's actually exceptionally fine filament linkages here, which are far finer than what you would actually get from the nozzle of the machine. So by controlling the machine in this very finessed way, we're able to actually push the material beyond what you would normally expect.
Typically, robots are used for handling equipment, pick and place, movement. And in this case, it's that precision of movement that makes it suitable.
This robot arm has a huge working envelope compared to a conventional 3D printer. So with this robot arm, we're quite interested in manipulating material in real time. And as a part of that, we need an interface, whether that's hardware or software, where we can actually instruct the arm to move in quite unconventional ways. So typically you'd want a machine to move efficiently in terms of speed perhaps, but we're actually more interested in getting the robot to move more like human gesture, and that might not be efficient in industrial terms, but it is efficient if you're considering perhaps the surface aesthetic of an object. So this arm represents an opportunity to sort of get right into the technology and rework it to our needs, and our needs are much more from an arts context.
Mitsubishi is one of the market leaders for small articulated arm robots, mainly based on the integrity of the control system. And because our control system is open, that's really the ability where the creativity can come in. So we have a standard machine connected to creative software.
We actually went around a couple of vendors and we had the best response from Mitsubishi. The Mitsubishi one ticked all the boxes, it did everything we wanted it to do, and then we were offered great support, and they helped us navigate that space of defining a robot purchase, what we would need and what our requirements were. And since the order, we've also had great support in developing the software and getting all of our research to work with the Mitsubishi technology. Technology is implicit in everything we do, and all we're doing here is actually pushing the boundary of what's possible. And I think that's interesting and should be interesting to everyone.